as a normal distribution with the given mean and standard deviation, find the indicated probability. So this is the between. This is the the best case for the calculator because it needs both an upper and a lower bound. Do you have your TI 8384 out, hopefully?
Yes.
All right, let me switch to that view and remind you where it is. You probably already know, but let me go and look myself. There it is. Okay. All right, so let me switch over to that. Okay. So if you're seeing my screen, hopefully you're seeing the calculator, and you go to second distribution. I'll type this up. Second distribution, which is above vars, and then you want normal CDF. You almost never do PDF. It's always CDF. So we'll choose that one. Mine doesn't have the nice options that yours probably has. So usually it needs like the mean and the standard deviation, and then the lower and the upper bound. So the mean in this case is 43, comma, yours will have this entered, standard deviation of 10, comma, 38, comma, 58. Okay, so when you copy and paste yours, you should get this normal CDF 43, 10, 38, 58, hit enter, and that's not correct. So I didn't put these in the right order, so I guess I need to go look. What's the first option that you see for normal CDF on yours, if you've got it handy?
Yes, it's right here. I have the for CDF. Give me 1 second. I have lower.
So the first number it wants is lower. Is that right?
Yes.
Okay, so that's where I went wrong here. So I got to give it 38, comma, upper 58, comma, the mean, comma, the standard deviation. And that looks to be the correct order. So it's upper, lower, mu, and then sigma, normal, CDF. I'm writing this down on the notes to look at later. So you round to 4 decimal places, so 0.6247. So give that a try and see if that that works.
Okay. The 4 decimal places.
Did that work?
Yes. Perfect.
Great. Okay, next question is exactly the same in terms of the steps, different numbers, slightly different numbers. So on your calculator, again, go to second distribution, choose normal CDF, and I'll write that here. It's normal CDF. And so it's going to be 51, 95. That's your lower and your upper, and then 80 and 10.
And it's CDF correct because it's not equal to, right?
It's CDF because it's continuous, and you never use PDFs for non-continuous functions.
Okay.
So the normal distribution is continuous because it's a nice smooth curve like that. It just so happens that it works really well that it's for between like this. I don't know. Is that clear?
Yeah, I got it.
Okay. All right, so I'm sure you want to verify your answer maybe. I can do that also. Figure out which piece of software I'm going to use. Actually, I'll probably use this one. Did you try your answer? Do you want me to check your answer?
Yeah, I did 3 and it's right.
Two or 3?
3.
Oh, you're up to 3 already. So you're really.
Oh, I did 2. Yeah, I did.
Okay. Okay. So 3 is no different. It's just another set of numbers.
Mm-hmm.
I'll snip it in and show you what to enter into the calculator. So again, it's another normal CDF, lower, upper, mean, standard deviation. All right, let me see if I can help here. Actually get some of the numbers. 7, 15. So I get for this one 0.3400.
Yes.
Great. All right, number 4 is slightly different. Let me see if there's any more like this, and then we'll come back to those so that we can get all the ones that are the same out of the way. So 6 is actually very similar. 6 is a word problem, but it's really the same thing. They just don't tell you what the values are. It tells you that it has a mean of 500 and a sigma of 100, and they want the probability that it's between 470 and 30. So it's the probability 470 less than or equal to x less than or equal to 530. And that's normal CDF again, 470, 530, 500, 100.
Gotcha. Yeah, that's simple.
You know enough now to do what I'm doing, which is teach someone else this. At least for these are all the same. So I get 0.2358 for that.
Yes.
Okay, let me keep going here. So 7 is the same.
Yeah, got that one.
You've done 7 already?
Yeah, I just did it.
Okay, great. 8 is the same.
Okay.
Uh, 8 though requires you to multiply by 100 with your answer.
Okay.
So maybe we
See if I did that right. Yep.
okay. 9, you take your answer and you multiply it by the 323,000. That's given in the problem.
Oh, okay, gotcha. So whatever answer I get, I multiply it by that.
Right. Now it's a little odd because you're rounding to the nearest 100,000. So that's the 6th decimal place or 6th place to the left of the decimal. So I will assist if needed on that. You get your number though, just like before. You get your probability.
So what is the lower number?
Oh, good. Okay, good. We finally got one that's different. Thank goodness. So your calculator requires a lower number. Okay, but here it wants higher than. It wants higher than 124. So 124 is actually your lower number.
Gotcha.
Okay, so now the question. Okay, well, thanks, Matthew. But what's the upper number? So it's a normal CDF. Your lower number is 124. Your upper number we'll get to in just a moment here. It's 95, 15. So what some instructors tell you to do is go like 10 to the 99. Okay, like basically like as big as it can be. That's way too big, but it probably will work. Sometimes it causes your calculator to break, to like, cause an error. Basically, you have to choose something that's big enough. So, and what is that? And it's generally whatever this number is, plus 6 standard deviations away from the mean.
Okay.
So like while 10 to the 99 does work, the better option is 124 plus 6 times 15, because it's more reasonable. That'll get you far enough away. So what I'm trying to say here is that the mean is 95, okay, and 124 is right here. You need to pick a number over here to the right, but you don't need to go out to 10 to 99 zeros. You just need to go out far enough.
Gotcha.
And like I'm suggesting like 214, for example, because it's 6 times 15 away. Now, having said all that, you get that number, but then you have to multiply it by 323,000.
Gotcha.
Now, and what I'm giving you today is a bit of a shortcut. It's not completely correct, but it does work on all the problems we're going to do. So you got something like 0.0266 for your area.
For the one we just did, correct?
Yeah. And did you already answer that one? Maybe you're already beyond this.
For 9, yes. I just got that like number and then multiplied it by
Okay, and you already have that answer. And
yes.
okay, 10. Okay, so 10 is similar. Let me snip that in. So your lower number, because it wants it here, it wants the probability greater than or equal to 0.4. So your normal CDF, your lower is 0.4. Your upper is to be determined. The average is 0.25 and the standard deviation is 0.03. So like what I suggest is 6 standard deviations away. So it would be 0.4 plus 6 times 0.03. Now, if you don't like that, just pick, 10. 10's far enough away, but it doesn't need to be 10 to the 99. That's kind of extreme for this.
Okay. Yeah, because when I do that on this one, it gives me like e to like the -7th.
Yes, and that could be a problem. So whenever you get this number though, because they want the number of batters, you have to multiply it by 250.
Gotcha. Okay. So the 0.4 plus 6 times 0.03.
That gives you this upper bound here. But you could just use 10.
Okay, gotcha. Gotcha. Oh, yeah.
Basically, it just needs to be a lot bigger than the number you have, or a lot smaller when it's the lower, but big enough that it gets to the end of the curve.
Okay, so when I did that, I got like the e to the -7th again, and then when I multiplied it by 250, I got like an e to the -5.
Okay, are you using 0.03 over here for your standard deviation, or perhaps maybe you got a
Well, when I used 10, I put 0.4, 10, 0.25, and 0.03. I think maybe 10's like too big.
maybe shouldn't be though. Let me just check this here. 0.25, 0.03, 0.4. Okay, this may be the first problem. It may just be 0.
I'm gonna try it because it's still giving me, even when I did.
Yeah, I'm seeing the same thing. There's another kind of variation on this that you can do, but I don't see it mattering here.
It was 0.
Yeah.
Makes sense.
Yeah. Okay, 11 is very similar. Gonna try that on your own.
Do I multiply it by the 10,000 jars?
Yes.
Okay.
When you're all done.
Gotcha. So 8 is my lower, correct? And
Yes.
would be
And
like,
your upper, so this is where you gotta be careful. Like if you choose 10, 10's not big enough. The standard deviation is 1. So like for me, a number like 80, like 10 times that number, another order of magnitude could be good.
okay.
You really only need to go out there to 14 for that one to make it work.
Okay. So I got 9,999, and when I rounded it to 10,000, it's wrong.
Okay, let me check this out here. So mean of 5.5, standard deviation of 1, and we want to go 8 or above. So it's above, right? So 8 to, so I'm getting 0 again for this.
Okay, then maybe. Oh, I put the mean and standard deviation incorrectly. That's why.
All right, that will do it.
So the mean is 5.5. Okay.
Yeah.
Gotcha. I got like I got 62.
Oh, you're okay. You're going out to more decimal places than I am. So yeah, that
Yeah.
Yeah, that seems reasonable. I'm only going out to a few decimal places.
Gotcha. Gotcha.
So, all right. Okay, 12, 13. 12 is unless you want to actually do it. I mean, as you know, you could just guess and check your way through that unless you don't get enough. Yeah, you get tons of submissions on that. We can look at 13.
Okay.
13, let me snip it in. There's a lot of extraneous information here.
Gotcha.
It really only wants you to look at task one here, which means you're looking at this row and everything else is irrelevant. Don't need it, don't care. Okay. You're asking for the probability that X is greater than 10. So we've been doing a bunch of these. It's a normal CDF. Lower bound is 10. Upper bound we'll get to. The mean is 17.8 and the standard deviation is 5. It's from the table.
Okay.
So what's our upper bound? Well, I've been saying this over and over again. It's like it's 6 times that number. So that's 30. You could put 40 here. You could put 400 there. It should be good.
Gotcha. And then am I multiplying it by anything? No.
Not in this one. Yeah.
Okay, so if that works. Yeah,
So we need to go back and do, I think, 5,
4 and 5.
4 and 5. Yeah. All right. Let me snip these in. Okay. So find B such that whatever that number is, the area between those two is 0.3. Okay, so they're saying like here is normal curve. It just so happens that 70 is right in the middle. So there's another value right here, which we're trying to find, that this area is 0.3. Is that a good are you comfortable with that, like this curve? Did you see that in class maybe?
Yeah.
All right. So on your calculator, which I will share in a moment here, but let me just look it up here. Yeah, there's an inverse norm on your calculator.
Gotcha.
Can you tell me what the first option is for inverse norm? It's under the normal CDF.
Yeah.
What does it ask for first?
Area.
Area?
Yes.
Okay, so the area that it wants is the left. Okay, so the left means left of this B value.
Mhm.
So that includes the 0.5 area that's over here, because 50% of it's left and 50% of it's right. So in your case, it's inverse norm 0.8.
Gotcha.
And then I guess it's probably going to ask for mean and standard deviation.
Yes.
Okay.
And then it asks for the tail if it's left, center, or right.
Oh, even better. I didn't realize it asked for that. So we maybe made this more complicated, but yours is going to be left tailed because we're going left of the B value.
Gotcha. And why do we know we're going left instead of right?
So the truth is you could do it either way. So if you have 70 B, and this is 0.3 here, how much is in the right tail? 0.2, because that's 0.5. So you could do the following. You could do inverse norm 0.2, 70, comma 4, comma right, and it'll give you the same answer as this one up here.
Gotcha. So it just depends on which way you want to go.
Yes, exactly. And it should be very clear before you take the test, which way to go, so that you don't second guess yourself on it
Gotcha.
on the exam. So let me know if you need me to check your number, but go ahead and enter it.
Gotcha. Got it. Perfect.
All right, so number 5. Number 5 is really similar. The difference this time is that they're telling you they want the area and the right tail to be 0.04.
Okay.
So you probably already know this, that it makes sense to use the right tail. So you give them the area and the right tail. 100, 10, right.
Okay. So once again, why did you say we used the right instead of like doing like
The,
0.54?
so the greater than or equal to tells you that it's right tail. In the
Oh,
previous problems, a little bit different. They wanted between. So it was kind of, this one was different. It's probably more difficult because there's this midpoint dividing it. If it said like x less than or equal to a is 0.04, then it's left-tailed.
okay.
So that those arrows tell you the direction of it.
Gotcha. Okay. Okay, I got 82.5, but it says it's wrong.
Okay, so it maybe thinks that 0.04 is this is where we're trying to figure out what the calculator wants. The calculator probably thinks when you say 0.04 that it's here.
Oh, because I
So
had it on left. I didn't change it.
oh, you didn't change it? Okay. Yeah.
That would be why.
Yep. Give that a try and see if it's any better.
Because it calculated the left side. Yeah, there we go. It's just because I didn't have it on right. Gotcha.
All right. Well, I think that takes care of 9.5. Hopefully you got full mark on that.
Yes. What time is it? We also have a written part, and I did the first half of it. There's just like a few I have some questions on.
Okay. Is this in your ebook?
Yes, and
All right. I'll open that up here.
oh, this first one. Oh no, never mind. It's all good. Well, the first one is on like a different website, but I don't know how he got to it.
You can,
So,
can you send it by email to me right now, or you can send it by text? Either works.
okay, like a picture of it. I mean, I could also say it to you if you wanted to write it down, but I can also send the picture if you.
Visual is always better. I'll
Gotcha.
inevitably hear or write something different than you say.
Okay, let me find it. One second. Oh, I can send the link in the chat too if that works.
Yes, that also works.
Okay.
We almost have too many options for
Really?
things. It's like we just want to see it. All right, so I will see if I can get this open. Here we go. This requires a login.
Okay. Then let me do a screenshot of it.
And you can also drop that into the chat also if it's easier. I'm gonna step away for 30 seconds. I'll be right back though.
Okay.
I am back.
Okay. I think I have it right here. Okay. And then I put the image in the chat. I don't know if it loaded yet.
There it is. Okay. Click to download. Download. All right. Let's see if we can just open it. All right. There it is. Yeah, I see a bunch of problems here.
Number 14.
All right. And you're supposed to do these by hand.
Yeah. We can use the calculator.
Okay. How's your calculus?
This is tough.
So the reason I ask is it does require calculus. So to find the expected value of x, it's the integral from 0 to 1. You can tell me if none of this looks familiar. F of x, well, which is 1 over 2 square root of x times x dx.
Yeah, I remember doing this last year and I was not a fan.
Okay, I will certainly work this out for you. So this part in parentheses or inside the integral here is the 1/2 is off to the side. It's 1 over x to the 1/2 power. This is x to the 1 up here. So it all simplifies to 1/2, and you can bring this 1/2 out. X to the 1 over x to the 1/2 is x to the 1/2 dx. So there's this power rule integral, which you add 1 and then you divide by the new exponent. So this becomes x to the 3/2 over 3/2 all times 1/2, and then you evaluate it from 0 to 1. And if none of this looks familiar, I mean, you haven't done it in a while. So the 3/2 here combines with the 1/2, so it's 1/2 times 2/3, and then you have this x to the 3/2 that you evaluate from at 0 and 1. So it ends up as these cancel. You get 1/3, and then it's x is 1, so it's 1 to the 3/2 minus 0 to the 3/2. So it ends up being just 1/3. And that's your expected value of x.
Okay.
Okay. And I didn't skip any steps. So like if you look back at it, maybe you'll remember some things from calculus or the brief calculus you took. Okay, now the variance of x is a formula. It's the expected value of x squared minus the expected value of x all squared. So we got that one, check, but we don't have this one. So the expected value of x squared, very excitingly, is the integral from 0 to 1 over 2 square root of x times x squared dx. So it's very similar to what you just did. It's just, different numbers. So again, like this simplifies to 1/2, 1 over x to the 1/2, x squared up here. And then 2 minus 1/2 is 3/2. So it's 1/2 the integral 0 to 1, x to the 3/2 dx. Power rule again. So you add integral power rule. So you add 1 to that. So it's 5/2 over 5/2, 1/2 here, evaluated from 0 to 1. All right. And so this becomes 1/2 times 2/5 x to the 5/2 evaluated from 0 to 1. So it ends up just being 1/5 times 1 minus 0, which is just 1/5. So the variance of x is 1/5 minus 1/3 squared, 1/5 minus 1/9. So you make your common denominator there, which is 15. And 45, not 15. And that's a 9 minus 5, so it's 4 over 45 is your variance of x. Sigma of x equals the square root of the variance of x. So it's the square root of 4 over 45. and you're done. So the numbers you need are, just to be clear, I'll box them in. You need this one. It's the expected value of X. You need this one. It's the variance of X. And then you need this one for the sigma of X.
Gotcha.
They would not expect you to replicate that on your own, but just,
Yeah.
it's, something you can maybe do. What else would you like to work on today?
On section 9.5 in the book.
Okay, I'll jump back to the book.
I know the first few are just like the ones we did on the like online homework, so those are pretty straightforward.
We can redo them. I can check them if you need. Are they graded for answer or just for completion, or?
These ones are graded for answer.
Okay, so which ones are they?
We start with 10.
10.
I put that into normal CDF, correct?
Yep. I'll get the answer independently, and you can do what you want with the answer. Meaning, hopefully it's the same as yours. If it's not, we can figure it out together. So let me get my calculator up. All right, 40, 20. All right, so I get 0.1974.
Yes, that's what I got as well.
Okay, what's next?
Then it's 14, which is the same.
Yep, same thing.
Okay, and then I just got 0.0684.
Yeah, I got 8.5, but probably close enough for
Oh, I just have to
most
round.
people.
Okay. And the next one is 20.
Okay.
Okay, and I think that's just the ones where it's like left or right thing.
It's inverse norm this time. So whenever they give you the area, that's when you use inverse norm.
Gotcha. So for this one,
So because these match, okay, they're telling you the center of this thing is at 10, and they want to the right of it, they want B over here. That's 10 less than or X less than B. This area is 0.4. So you can either go right tail with 0.1, because this is 0.5, or you can go left tail with 0.9.
Gotcha. So when it's like when there's an X and it's like two numbers,
Yes.
that's when you would like add them together.
Yeah. It looks like your instructor's only emphasizing this like midpoint. There's other variations on this, but this is good enough, I guess.
I got 16.4.
Yeah, give me a moment here to catch up to you. I'll
Gotcha.
let's see here, 0.9, and no, this is not that's not what we want. All right, so we want 0.9 there, and mean of 10, standard deviation of 5. I get 16.41.
Yeah.
That seems reasonable. Okay, great.
And the next one is 22.
Okay. This is just like the 4 and 5 that we did. So
Yeah.
it's good practice because it's just a repeat with different numbers. So here the picture is kind of important. When it says X greater than A, they're telling you that this area right over here is 0.03. So make sure you're using right tail on your calculator. And it's an inverse norm again. Whenever they give you the area, it's inverse norm.
Okay, so if it's just like just one number like that, like if it's X is greater than or equal to A and then they give it to you,
Mhm.
I would just put in 0.03, correct?
Yes.
Gotcha. So it's
The number has to be bigger than this also, because if you look like where the mean is, it's there. So like your number better be over here. Like it better be bigger than 10. It's
gotcha.
just kind of a reasonableness check.
So
on it.
only if there's like two numbers or like the last one, that's when you
Yeah.
would do.
Yes.
Okay.
So I get 19.40.
So did I. Perfect.
Excellent.
Okay, and then the next one is 32.
Okay. Do you get written problems like this with all of your assignments?
Yeah.
Okay. All right. Refers to 31. Okay. I love those. Why can't they include the information? All right. So 31 tells you the mean is 100. The standard deviation is 16. And they want the probability here is 80 and 90.
Is this just like normal CDF?
It is.
Okay. Okay, I got 0.16.
All right, let me get caught up to you on this. Yeah, I get, so it says round your answer nearest percentage. So yeah, 0.1603, but then you multiply by 100 and it's 16%.
Gotcha. And the last one is 40, which I assume is the same. No, it's not. Okay.
Yeah, I mean, you're doing something like this one. You find the area, the probability, and then you multiply it by 300,000, it looks like.
Okay. So I still use normal CDF, or do I use something now?
So below 9, see how it says below 9 there? So this is the probability that X is less than or equal to 9. So yes, it's normal CDF, but this is was the first one we've had where we didn't, like, that's the upper value, 9. We got to figure out the lower value.
Oh, right.
So the mean is 12 and the standard deviation is 2.5. So it's got to be a lot less than 9, and it can be negative. So I mentioned like 6 times this number. You know, you could use 10 times that, or just, you can go like -50. That'll give you a good enough answer on there. You take that number there, whatever you get there, and you multiply it by 300,000.
I got a negative number.
For normal CDF?
Yeah, because I put in -50 and it gave me like negative 0.11.
Right, let me try this myself. Let's see what we got here. Did you get your mean and standard deviation in the right place? 12 and 2.5. They're not swapped.
Yeah, they're in the correct spot.
Okay. 12, 2.5. All right, -50 and 9 here. Yeah, I mean, I get 0.1151 when I do this.
For upper, do I put -50?
No, this is the lower.
Okay,
See,
wait.
this one's different. So it says below 9 here.
Oh.
It's the only one we've seen like that where that number is now here in the upper. You're used to putting the upper you're used to the X greater than, and then figuring out what the upper value is. This one's the flip of it.
So the lower number, I would put -50 or just 50?
Yes, -50.
Okay,
Because it's got to be a lot smaller than 9. And
then times 300. Okay, yeah, I got like 34520.9.
and then you multiply that by 300,000.
Yeah, that was like the after I multiplied, like,
Yes.
okay.
So I get 334,521.
Yeah.
Great. Bottles of hot sauce.
Perfect. That is all I have for tonight.
Great. Well, thank you so much for scheduling, and let me know if I can help again.
Thank you. Thank you for your help.
You're welcome. Have a great night. I'll see you next time.
Bye.